Hello, everybody. My name is Connor Thompson. This is my Physics 2212 Lab 4 report. This lab is a magnet-based lab that requires us to measure the distance dependence of a small bar magnet's magnetic field and compare these measured data values to ones predicted by a glow script code. We used a phone to measure magnetic data placed in a ruler. Magnet was placed at the end of the ruler to measure certain distance dependence values with the phone, similar to how it's demonstrated here. This lab primarily dealt with the Biot-Savart law, on-axis B field formulas, magnetic field equations, etc. The phone's magnetometer is a system in the Earth, and nearby bar magnet is the surroundings. Um, our main result was like these principles that as distance from the magnet increases, as measured by the phone, magnetic field impact decreases. Magnetic field acting upon the phone is twice as strong when they're parallel to the bar magnet than if it were perpendicular to the bar magnet. D perp was about 0.186 meters. By Earth T was -5.46. B net T was 58.29. LNBX versus LNR, the graph that we'll see here in a second, was -2.8731x minus 0.3856. And that graph is what I was talking about here. This was the overall Excel graph results from the whole experiment. You can see things like the D perp, the B by Earth, the net B, and all of these sort of things, the different distances and the different R values. And this was the graph produced by the glow script code. You can see that the D was 0.263, which is a little off from what you would expect here, which could be due to some errors we'll get into later. This was just the overall glow script code. This was the code used to produce the four different arrows that you see to represent the magnetic field perpendicular to the axis. And yeah, the background of the experiment, the magnet placed at the end of the ruler with the phone-based magnetometer sitting along the ruler a specific distance away from the magnetometer. So you can see at a given distance, to calculate like these R values, for example, there was a specific distance that you needed to have it at to get those R values, and those are measured. For the overall general experiment procedures, you had a bar magnet placed at one end of an east to west oriented directed ruler with the axis pointed parallel to the ruler. The phone was placed perpendicular, similar to how you see here, to the magnet along the ruler at a short distance away from the magnet. This procedure was used to determine multiple different values and sometimes involving different orientations of the phone. Sometimes we rotated it parallel. For instance, the X and YZ components of the magnetic field at the phone's location on the ruler. These were values that we determined, such as like right here, for example, the different R values. We determined these different values based on this location and based on the app. D-perp was calculated in a similar manner by positioning the phone perpendicularly along the ruler in a location that would produce a B net value of 100. Let's just to give an example. The distance between the magnetic sensor on the phone, the red X in the photo right here, location of the sensor, this distance between this and the magnet was the D-perp value. Just again, these are the components of the experiment results. We already kind of went into this. And one of the assumptions we made is we assumed that the only acting forces on the magnetometer were due to Earth and the magnet itself, though there could have been nearby electronic devices and any other potentially magnetic field producing objects that were neglected. For what if we hadn't oriented our experiment to compensate for magnetic north? The magnetometer data would be significantly more varied in the x direction, which consequently would have changed the n and k values on account of the additional interference by Earth's natural magnetic field that wasn't being offset by the east-west orientation of the ruler. Um, what if you were to stick two identical magnets together, or two identical magnets together, and run the experiment again? Well, we would assume that the magnetometer would likely detect a doubled magnetic field with no directional change, because since there's two magnets, the magnetic force would be doubled just overall. Um, to conclude, some big error sources could be nearby electronic devices, other sources of magnetic fields, the movement of the phone, poor magnetometer app, a faulty magnet ring, inconsistencies in measured trials, because you had to measure uh, each value of these multiple times and get an average. As you can see right here, there's multiple trials. And then overall, this experiment was very interesting in showing how magnetometers can detect strong magnetic fields and how these magnetic fields relate to other factors like the Earth's own magnetic forces. Thank you for watching.